Hi, and welcome to Allen High School. We're talking about bonding, and now we're moving into molecular shapes based on Lewis dot structures. And the model that we're going to be using is called the valence shell, because it's the valence electrons that are involved in bonding. And then we're going to be looking at how electron pairs, remember we're putting electrons on in pairs now, how they repel one another, and how that repulsion then dictates the three-dimensional structure. I'm going to walk through this with you to provide a framework, but I want you to realize that it really won't be until we build models or you see these in the classroom and on some videos, see them rotating, that I think it'll really click into place. All right, but the key premise of this is that the bonds, the valence electrons, the bonds on peripheral atoms repel one another, okay? And because of that, we're going to get a shape. Now, when we've got a central atom, remember we use the symbols A's and B's and X's. So when we have this, right, there's electron pairs, there's an electron pair, there's non-bonded. All right. The electron pairs repel one another, and they want to get far apart, but the non-bondeds repel even more because they're pretty free. They like a lot of personal space. And because of that, we're going to get a three-dimensional shape. Now, to speed things up a little bit, I went ahead and did these Lewis dot structures, assuming you know how to do them. So number of bonded atoms, number of peripheral atoms is 2. There aren't any non-bonded pairs. Remember, beryllium, even though you might think it's ionic, beryllium likes to pretend it's a little bit covalent, but it's okay with just 4 electrons. So this would be considered an AB2. Well, for these electron pairs to get as far apart as possible, they would form a line. And so this is linear. We're going to talk about polarity later. We'll fill in that gap there. All right. Now, in boron, remember too that boron is also one that takes less than an octet. You have to memorize that hydrogen, boron, and beryllium take less than an octet. So I've got 3 peripheral atoms. I have 0 non-bonded pairs. So this would be an AB3 structure. And to get as far away as possible in three-dimensional shape, this forms a triangle in the plane. So we call it trigonal planar. Now this next one's a little tricky. Let's just do this. I think you see this. This is 4 and 0, right? So this is an AB4. Now, if this was just on 2 dimensions on a plane, it would form a square. But it's not. This is in 3 dimensions. They can get further away than that. And it forms a tetrahedral structure. That, again, we're just going to lay the frameworks. We have the chart as a reference point, and you'll see that structure, I think, a little more clearly when we get into class. All right, let's take a look at this next one. This next one is an AB3X structure, right? It has that non-bonded pair that we call an X. And this is called trigonal. It's got a triagonal base. And this phosphorus goes up to a point. So it's like the phosphorus is there, the hydrogens are down, and the non-bonded pair is up. So we call that trigonal pyramidal. Now, what the water does to get as far apart as possible is we'd have an H and an O and an H, and the non-bonded pairs would both spread out as far as possible. And so this is an AB2X2, and that's bent. This next one is AB5. It's trigonal bipyramidal. Okay, and then we have one more, and then I'm going to backtrack and show you the expectations. This is AB6. Selenium hexafluoride, we're going to call that AB6, and this is an octahedral structure. Now, here's the expectation. The expectation is that you are able to go from a formula to the Lewis dot. Then from the Lewis dot, you can figure out that generalized ABX structure. If you look online, you'll see similar things, but they might use different letters here, but it's the same concept. And then here's what you have to do. You have to memorize from here to here. So what we're going to find is anything that is AB4 is tetrahedral, even though I can't spell tetrahedral apparently. Tetrahedral. Anything that is AB4 is tetrahedral. All right? Now, anything that is AB3X is trigonal pyramidal. All structures. So you go from formula to Lewis dot. From the Lewis dot, you figure out the AB, and then you memorize the structure. All right? And you have to memorize all the ones that we've covered up through this one. Okay? All right, then we're going to talk about polarity. So until then, this is saying good night.